The next thing we're going to talk about is specific heat. And specific heat is a property specific to each object or each substance that determines how much heat needs to be added to raise the temperature of the substance. So specifically, when we talk about specific heat capacity, we're going to be talking about how much energy it takes to raise the temperature of an object by 1 degree Celsius. But specific heat generally is just talking like how much energy does it take to move the temperature up and down. Something with a high specific heat takes a lot of energy to change its temperature. It can store it like water. Something with like a low specific heat capacity would be some type of like paper would not need a lot of energy to change its temperature. Going on from there, let's look at the equation for specific heat. We have Q, which is the heat, is equal to, and a lot of people like to remember this as MCAT, but it's MC delta T. So it kind of looks like MCAT. Here is heat, that's in joules. We have our mass in kilograms. We have I have my C and delta T my C and delta backwards. MC delta T, that's why it's a cat. So C is our specific heat capacity. Let me double check on the units so I don't give you something wrong here. Well, we'll write it in a second and figure it out based on these. And here's our change in temperature. It can either be in change in degrees Celsius or change in Kelvin. Remember, the separation on those is identical, so it doesn't make a difference. Meaning in this one that it should be joules per kilogram degree Celsius, or it could be joules per kilogram Kelvin. Cool beans? Cool beans. So let's look at the sign conventions for specific heat. This is going to tell us whether something is positive or negative. So here is where we are absorbing energy, and here is release. Here is Q, and here is delta T. So when we absorb heat, we should have a positive. If we release heat, it'll be negative. We have a positive temperature change, we're absorbing energy. Negative temperature change, we are releasing energy. So I'll pose this question to you guys. Why do coastlines have a more consistent year-round temperature than inland locations? And I will give you a hint. It has to do with what we talked about just a second ago with specific heat capacity. So I'll give you a second to think about it, pause the video, give it some thought, then we'll be right back. Did you think about it? Well, it's because water. So water has a lot of heat storage because it has such a high specific heat capacity. It's one of the highest substances that we know. So what happens is during the summer, the water will store a lot of that heat. And then in the winter, it'll slowly release it up and keep the air warmer than it would have been. Inland places have just like rock and dirt and soil. And while that can store some heat, it's going to change much more quickly. So the rate of heat removed from water and the ground are going to be the same. So the rate at which energy is taken away. But because water has such a higher specific heat capacity than like soil, the delta T is going to be a lot smaller for the same change in Q.
So that's why oceanside places tend to stay a lot more temperate in the winter than inland places.